So remember, once you have removed the tissue, you have to preserve the tissue as soon as possible. So this is to prevent the DNA from degradation and also denaturation. So DNA is a molecule like many other molecules. DNA can degrade and denature easily. So just now we talked about the degradation and denaturation. So both are not good for DNA, but these are the different type of the damage on the DNA molecule. So you have to know what is the degradation, what is the denaturation, and what caused the degradation and what caused the denaturation. If you know the cause of the DNA degradation and denaturation, then you can do something or use any chemical to reduce the cause. So you have learned this before, so I'm going through quickly. So this is a nucleotide. You know that the DNA is a double helix molecule, and each of the nucleotide is connected with the phosphate bond. A pair of the strand of the DNA is attached to each other with the hydrogen bond. Okay. So for DNA degradation, is referred to the fragmentation of DNA molecule into the nucleotide. Okay, so that means that this phosphate bond is disappear. Okay, it's damaged. Or the carbon-nitrogen bond, which is this one. Okay, this is a carbon, this is a nitrogen bond. Okay, for example, this one. Okay, so the main cause of this degradation is the oxidation effect, autolytic effect, a process. Okay, for example, some enzyme activity. So this will cause the DNA double helix structure, still with double helix structure, but it will break in the smaller fragment. So for denaturation, it will not affect the primary structure. Okay. So it's mainly referred to the breaking of the covalent bond. Okay, this bond between both strands of DNA. Okay, so you can see the primary structure is still intact. So the cause is mainly due to the hydrolytic effect. So now we know the the cause of the DNA degradation and denaturation. So there's an oxidation effect, autolytic effect, and also the hydrolytic effect. So we can look for the way to minimize all this effect and activity. So one way to do it is to keep your sample, your tissue in low temperature. Then you can lower the enzyme activity and exclude the light or other radiation. So in this way, you reduce the oxidation effect. You also can remove the water, then you can reduce the hydrolytic effect. Okay, so these are the things that you can do. So for oxidation, you also can remove the oxygen. Okay. At the same time, you also can sterilize your sample or the surface of your sample. Okay, reduce the microbial, so you reduce the DNNH activity. So we know that these are the principles, then we can choose the method. For example, to keep the sample in a low temperature, you can keep your sample in freezer in different temperature. If you want long-term storage, it's better to keep in a very cold and agent environment. To exclude the light, you can store the sample in a dark cabinet or room, or use the aluminum foil to wrap the glass bar. Okay. To remove the water, you can air dry the sample by using the food dryer, or you can use the silica gel, okay, to remove the water from the sample. And you also can use ethanol to replace the water in the tissue with the ethanol. To remove oxygen, you just store your sample in an airtight container. To sterilize against the microbial, so you have to make sure you wear the hand glove and sterilize all the apparatus, okay, by autoclave or by Bunsen burner. So these are the few simple things you can do. So when you want to preserve a sample, usually you use a combination of few of these methods.